Introduction. Understanding the need for enharmonic equivalence. Music theory can be both fascinating and perplexing, especially for students encountering concepts like B sharp, C flat, E sharp, and F flat for the first time. One common source of confusion is the question, why do these notes even exist if they sound the same as C, B, F, and E? This confusion often stems from an initial focus on simplicity in notation, which leads to an incomplete understanding of musical logic. This curriculum aims to break down the reasoning behind these enharmonic equivalents. By understanding their theoretical necessity, students will gain clarity and confidence in reading, composing, and performing music. The journey starts with the foundations of music notation and progresses to more complex ideas like chromaticism and modulation. Let's begin by demystifying music notation itself. Chapter 1. Introduction to Music Notation. Objective: provide a foundational understanding of the musical alphabet, sharps, flats, and the construction of steps within music. 1.1. The musical alphabet. The musical alphabet consists of 7 notes: A, B, C, D, E, F, G. After G, the sequence repeats. 1.2. Whole steps and half steps. A whole step is the distance between 2 pitches that skips 1 note, for example, from C to D. A half step is the smallest interval between 2 notes, for example, from E to F. Key point: a half step is the building block for sharps and flats. 1.3. Sharps and flats. A sharp raises a note by a half step. Example: C sharp is a half step above C. A flat lowers a note by a half step. Example: B flat is a half step below B. 1.4. Natural notes. Notes without sharps or flats are called natural notes. Example: C, D, E, as opposed to C sharp or E flat. 1.5. Why do some notes seem to break the rules? When moving up or down the scale, some half-step transitions appear automatic. E to F and B to C are natural half steps. This can cause confusion when introducing sharps and flats. Example misunderstanding. Students often believe there's no such thing as B sharp because B naturally progresses to C. However, in some contexts, B sharp is essential to maintain theoretical consistency. 1.6. Why enharmonic equivalents matter. In some scales and chords, using sharps or flats in specific ways is necessary to maintain the correct structure of the scale. Avoid breaking the rule that each letter in the musical alphabet appears only once in a scale. Preview. In the next chapter, we will introduce the concept of enharmonic equivalents and their role in scales, key signatures, and chromatic passages. Music notation uses a set sequence of letters, AA to G. Sharps and flats modify notes by half steps. Understanding whole and half steps is crucial to grasping why notes like B sharp, C flat, E sharp, and F flat exist. Next up, enharmonic equivalents, the basics. Chapter 2. Enharmonic equivalents. The basics objective. Explain the concept of enharmonic equivalents and demonstrate their necessity in theory and notation. 2.1. Definition of enharmonic equivalents. Enharmonic equivalents are notes that sound the same but are written differently. Examples: B sharp and C, C flat, and B, E sharp, and F, F flat, and E. 2.2. Why do we use enharmonic equivalents? Enharmonic equivalents are used for consistency in key signatures and chord spelling. They ensure that each note of a scale has a unique name. 2.3. Practical examples of enharmonic equivalents. B sharp and C in the C sharp. Major scale, C sharp, major scale, C sharp, D sharp, E sharp, F sharp, G sharp, A sharp, B sharp. The 7th note is written as B sharp rather than C to maintain proper scale structure. C flat and B in the G flat. Major scale, G flat, major scale, G flat, A flat, B flat, C flat, D flat, E flat, F. The 4th note is written as C flat rather than B for consistency with flats. Enharmonic equivalents simplify notation while keeping scales and chords consistent. They serve an important function in music theory, even though they sound identical in equal temperament tuning. Next up, the role of key signatures. Chapter 3. The role of key signatures. Objective: demonstrate how key signatures dictate the use of sharps, flats, and enharmonic equivalents. 3.1. What is a key signature? A key signature defines which notes in a piece of music are consistently sharp or flat. It helps simplify the notation by avoiding excessive accidentals. 3.2. Maintaining consistency in key signatures. In sharp keys, sharps like B sharp are used to avoid breaking the sequence. In flat keys, flats like C flat are used similarly. Example, in the key of F sharp major, the leading tone, a half step below the tonic, is written as E sharp, not F. 3.3. Avoiding double letters. Each note in a scale should only appear once. In the C sharp major scale, B sharp is used instead of C to avoid repeating C twice. Key signatures provide structure for scales. Enharmonic equivalents help maintain that structure. Next up, enharmonic equivalence in chromaticism. Chapter 4. Enharmonic equivalence in chromaticism. Objective: explore the role of enharmonic equivalence in chromatic scales and passages. 4.1. Introduction to chromaticism. Chromaticism involves moving in half-step intervals. Chromatic scales use all 12 notes within an octave. 4.2. Enharmonic choices in chromatic passages. When writing chromatic scales, using enharmonic equivalence can clarify the musical direction. Example, ascending. E, E sharp, F sharp, G. 4.3. Practical implications for notation. In fast chromatic runs, enharmonic equivalents help maintain consistency and avoid unnecessary complexity. Chromaticism relies on half-step movements. Enharmonic equivalents make chromatic passages clearer in notation. Next up, theoretical versus practical application. Chapter 5. Theoretical versus practical application. Objective: distinguish between theoretical correctness and practical ease in performance and notation. 5.1. Theoretical correctness versus practical notation. Music theory provides precise rules for naming notes to maintain logical consistency. In practice, musicians often simplify notation for ease of reading. Example, a pianist reading a complex chromatic passage may prefer to see C instead of B sharp. 5.2. When does theoretical notation matter? Classical scores, theoretical accuracy is often followed strictly. Jazz and modern notation. These genres often opt for simpler enharmonic equivalents. 5.3. Impacts on performance. Proper notation ensures performers understand harmonic structure. Example, in an orchestra, the conductor may insist on B sharp instead of C to reflect the harmonic context. Improper notation can lead to confusion in ensemble settings. 5.4. Enharmonic modulation. Enharmonic modulation uses notes like B sharp and F flat to shift seamlessly between keys. While some contexts allow for simplification, precise notation is important for understanding musical intent and maintaining harmonic clarity. Next up, chord construction and enharmonic spelling. Chapter 6. Chord construction and enharmonic spelling. Objective: explain how enharmonic equivalents affect chord spelling and progression. 6.1. The role of enharmonic equivalents in chord construction. Chords are built from specific intervals, for example, major thirds, minor thirds. Changing a note's spelling changes its harmonic function. 6.2. Examples of enharmonic chords. C diminished. Triad, correct spelling, C, E, flat, G flat, incorrect spelling, C, D sharp, G flat, even though they sound the same. F sharp 7, resolving to B sharp diminished, correct resolution. F sharp, A sharp, C sharp. E resolving to B sharp, D, F. 6.3. Avoiding ambiguity in progressions. Proper spelling prevents ambiguity in harmonic analysis. Example, writing E sharp instead of F clarifies that the note functions as a leading tone. Chord spelling relies on enharmonic equivalence to maintain functional clarity. Accurate notation supports better harmonic understanding and smoother progressions. Next up, enharmonic equivalence in modulation. Chapter 7. Enharmonic equivalence in modulation. Key changes. Objective: demonstrate how enharmonic equivalents are used to facilitate key changes. 7.1. What is modulation? Modulation is the process of changing from one key to another within a piece. Enharmonic equivalents often serve as bridges between keys. 7.2. Enharmonic, modulation examples. G minor to B major, the diminished 7th chord, F sharp, A, C, E flat, acts as a pivot, with enharmonic changes aiding the transition. 7.3. Why use enharmonic equivalence in modulation? Simplifies the notation of key transitions, maintains clarity for performers following a complex score. Enharmonic modulation smooths transitions between distant keys. These equivalents provide theoretical consistency during key changes. Next up, historical and tuning system perspectives. Chapter 8, Historical and Tuning System Perspectives. Objective, explore the historical and tuning-based reasons behind enharmonic equivalence. 8.1. Historical context of enharmonic notation. Early composers used enharmonic equivalence for expressive purposes. In Baroque and classical music, enharmonic shifts symbolized emotional or dramatic moments. 8.2. Tuning systems and enharmonic. Notes equal temperament. The modern system where all enharmonic equivalents sound the same. Just intonation. A tuning system where B sharp and C may differ slightly in pitch. 8.3. Practical impact of different tunings. In early tuning systems, using B sharp instead of C could change the harmonic color. Today, equal temperament allows composers to use enharmonic equivalence without noticeable pitch differences. The evolution of tuning systems has influenced how enharmonic equivalents are perceived. Modern notation relies on equal temperament, where enharmonic notes sound the same. Next up, real-world applications for composers and musicians. Chapter 9, Real-world applications for composers and musicians. Objective, highlight how composers and musicians apply enharmonic equivalence in practical settings. 9.1, composition techniques. Enharmonic equivalents add richness to modulation and chromatic passages, used to simplify complex harmonic structures in scores. 9.2, performance strategies. Musicians should be familiar with enharmonic equivalence to sight read accurately. Understanding enharmonic shifts can aid in quick key changes. 9.3, examples from classical and modern music. Classical, Beethoven's use of enharmonic modulations for dramatic effect. Jazz, chromatic progressions often include enharmonic substitutions for smoother transitions. Composers and musicians use enharmonic equivalence to enhance musical expression. Mastery of enharmonic notation improves performance and interpretation. Next up, exercises and practice. Chapter 10, exercises and practice. Objective, reinforce understanding through practical exercises. 10.1, scales and key signatures. Write out major and minor scales using enharmonic equivalence. 10.2, chromatic passages. Practice ascending and descending chromatic scales with proper enharmonic notation. 10.3, chord spelling drills. Identify and correct enharmonic errors in chord progressions. 10.4, composition challenge. Write a short piece using enharmonic modulations. Hands-on practice reinforces theoretical knowledge. Exercises help students become confident in using enharmonic EQ. Thanks for joining. Like, subscribe, and share.